I will be talking about improving the reliability of Cloud Foundry applications through advanced health checks. So this is just one feature that our team implemented recently. So not the only feature. And yeah, just want to show you it as an example to show how we approach new features and how we want to resolve them. All right. So first, let me introduce myself. My name is Maria Shaldybin, and I work as a software engineer at VMware Tanzu. And I have been working on Cloud Foundry for around 10 years. And I worked on different parts of Cloud Foundry, like Bosch, Diego, Concourse, and CFCLI. And I used to give talks on Bosch. But I broke up with Bosch, and now I'm with Diego. So I haven't done any talks for a while, and I was just talking about it like, I don't remember when was the last time I spoke for 20 minutes straight, because I work with computers, and also I have 2 kids, 6 and 4. And so whenever I try to talk to my 6-year-old and trying to give life wisdom, that the school is important, within a minute he would be like, "Mommy, please stop talking." But yeah, so that's what we're gonna do. It was pretty exciting to see Cloud Foundry and how it evolved as a project. As James mentioned, it started as this whiteboard project, and how at first it was file system based isolation, process-based isolation, and then over time migrated to C groups, and with all these new features that were added later on and how it was extended, and now it's being used worldwide. So that's all have been pretty exciting. And also that's the first open source platform as a service. Okay, so kind of remind this to everyone, what are the key objectives of Cloud Foundry? And I think this is what differentiates Cloud Foundry and from other systems and from other similar solutions. So Cloud Foundry provides this consistent, reliable environment for running applications, and it enables rapid application development, deployment, and scaling. And that's why users love Cloud Foundry. They come back to Cloud Foundry because reliability is one of the main goals of Cloud Foundry. And talking about application reliability in Cloud Foundry, we can view it from these 2 aspects. One is we want to ensure that application instances are available during application lifecycle, and actions that are triggered by application developers, like updating application code or application reconfiguration. And then, on the other hand, we want to provide tools and mechanisms to withstand failures and disruptions that are caused outside of application developer control or even platform control. And these are the mechanisms that Cloud Foundry provide to ensure the reliability during application lifecycle. So all the application updates are performed in a rolling fashion. So new version of the application first is being deployed. Once it is successfully deployed and successfully running, this is when the old version is being replaced with the new version. The update happens instantaneously. since behind the scenes, Cloud Foundry switches the routes from old version to new version. And there are tools to also perform blue-green deployments for applications using, again, routes. And platform constantly monitors application instance health using health checks, and then performs actions like swiftly recovering them. There are also different mechanisms to configure load balancing across the application instances. So like one of the recent features that we added is to prefer availability zone. That's to minimize the latency when HTTP requests are performed to application instances. And also at the same time, you can configure routers to load balance requests between application instances, and platform will spread them across availability zones. Also, we want to ensure that all the reconfiguration and any updates to application configurations are happening without application restarts. So this can be done by updating environment variables or binding and unbinding services like config servers or credential storage servers like Red Hat. And then we can look at reliability during some disruptions that happen outside of the platform control. So there might be application crashes, like syntax bugs or memory leaks. In that case, Cloud Foundry will bring up crashed instance immediately. Also, there might be networking failures, and in this situation, it is important to design the platform so it withstands this kind of failures and deploy VMs and Diego cells and routers across availability zones. And then there might be infrastructure failures, like VM becomes unavailable. And here I want to just to tell one story. It was like Saturday morning. I was walking in the park with my kids, and then I took a picture of them and I wanted to post it on Instagram. And I got this server error, and I was like, what? Instagram is down? It was kind of funny, but then within like 30 seconds, I got pager duty alert. So apparently the whole like AWS availability zone like was out. And that affected our production environment. And I was on call with Alex Surachi, who is a very talented engineer. And he wrote a bunch of tools, including Spiff. But it was just like, I think he did it on the weekend or something. So, but anyway, we tried to resolve that incident and basically brought up all the missing Diego cells and routers in another availability zones. And it was like, at that point, you felt the power of Bosch and Cloud Foundry, how easy and quickly it was to bring desired state, how easy it was to bring the platform to the desired state, and we didn't have to do much, just deploy and just change one variable, which was the name of availability zone, and deploy, and all VMs came up, and then Diego took care of bringing up all the missing application instances, and it took like 2 hours maybe, but it was, we had another availability zone, so it was an easy process. Yeah. Okay, so let's talk about the health checks and the benefits of using advanced health checks. First, they provide enhanced monitoring for your application instances and proactive issue detection. So if application developers utilize these health checks, they can improve overall reliability of their applications. And why we needed improvements to Cloud Foundry health checks? In their original form, they were too aggressive because the only action they were taking is to restart applications. So whenever the health check was failing, Cloud Foundry would restart the whole application instance. And we were getting these complaints from users and clients that it might be too aggressive. And we wanted to expand this with extra functionality. And here, I kind of want to mention, like, as part of our process, what do we do usually? Sometimes we get requests from clients, or they coming up internally in our team. And I want to give kudos to Amelia. She is driving the open source involvement for our team, making sure that we have an open issue for our community to discuss any upcoming features. And let's talk about it. Everyone can bring their ideas. And it's great because community brings ideas and also thinks about some edge cases we might not think about. So yeah, there might be cases like connectivity issues or warm-up period, and we don't want to completely restart our application instances in that case. And now we have these three types of application health checks, which is startup, liveness, and readiness health checks. Startup health checks runs when application instance is being started. If it doesn't come up within the specified timeout, then Cloud Foundry doesn't do anything about it, and it delegates decision to application developer. Why? Because it probably means that something wrong with configuration for that application. It wasn't able to start up on that platform, so application developer needs to decide what to do with it. And then once startup health check succeeds, Cloud Foundry will run liveness health check, which periodically checks, let's say, like for HTTP, health check some endpoint. And if it fails, this is when the application instance is being restarted. And then the readiness health check runs in parallel. And if it's configured, the outcome of the failure would be that that application instance is just taken out of the route pool and is no longer routable, but it will be running. You can SSH to it. And so this is for the case when there is a temporary issue with that application, and we don't want to restart the whole application because that might be too costly. So each of these types, startup, liveness, and readiness, can be one of these health check types, which is port, HTTP, and process. And process is the default one. If no health check type is configured, that's one that will be used. And basically, it checks that all the processes are running. If at least one of them is not running, then depending on if it's liveness health check, the application will be restarted. Or if it's readiness health check, then it's not going to be routable. And then HTTP is the one that validates HTTP connection to the specified endpoint, and it should return 200 OK. So I think this is the one that gives the most control to application developers, since they can decide based on their terms what do they want to do with that application. Do they want to take it out of the route pool, or the way they implement response to that health check call. And then the port is basically a TCP connection checking that, can I connect to that specified port? And this is a diagram. This is what happens when application developer pushes an app. The startup health check runs first. Within a specified timeout, it needs to succeed. Otherwise, that instance is treated as failed. Platform doesn't do anything about it. Then the liveness health check starts if that startup health check succeeds. And it periodically checks on interval, and then the outcome of failure is that app instance is restarted. And then the readiness health checks, if it's configured, will be running in parallel. And if it fails, the app instance is not routable, but it keeps on running until it succeeds again and the app instance becomes routable again. And then let's talk about what happens during the crash event. So first, the status change to crash. The error message will appear in the app logs. In the app events, there will be crash event. And then, as I said, during startup, if it fails during startup, nothing is happening. But if it happens during the liveness health check, then this is the dance that platform performs. It will attempt to restart this app instance. After 3 failed attempts, it waits 30 seconds, then doubles until 9th attempt, and then until 200th attempt. This is when it's, OK, I'm giving up. And this will take several hours. So if there is any temporary issue, it should be resolved. And these are the configurations parameters that I use for liveness health check. And they don't have liveness prefix for backwards compatibility. But then if we look for readiness health check, the readiness, they have readiness prefix in front of them. So you can configure type, endpoint, and timeout. And this is the timeout for each individual health check call, like for TCP connection to timeout, for HTTP request timeout, and then the interval. And this is how you would put it in the manifest. You would have liveness health check type, and then you would specify readiness health check type and configuration. Like for HTTP, you can provide an endpoint, and then this is what happens behind the scenes, that the app container is created. Once liveness succeeds, the process is running, and you can SSH to it. And then once the readiness succeeds, the HTTP server is ready to serve HTTP requests. And then we can talk about use cases. So as I mentioned, if application needs some time to warm up, let's say it's cache, then you can configure liveness to be type of process, readiness with type HTTP, with some endpoint that will return 200 only after that app is ready. And this would be another use case is, let's say we have a Spring application, and sometimes it might have connectivity issues to the database. So in that case, you would configure liveness health check as type process. And then Spring applications can be configured with this dependency called Spring Boot Starter Actuator that will add an endpoint actuator health to the application. And readiness health check can be configured to point to that. And this endpoint will only return 200 OK when all the dependent services of Spring application are up and running. So if we go beyond the health checks, application developers can utilize the log aggregation for their application instances. and they can use application metrics and set up alerts and notifications for application metrics. And also, they can use distributed tracing to trace all the HTTP requests that come into application. And also, recently, we added support for distributed tracing internal across Cloud Foundry components. So when you do CF push, you can see how, like, the full flow of that request, how it hits router, cloud controller, auctioneer, BBS, Diego cells, and you can see all the logs related to that specific request.